Okay, now what we're going to do is try to find the inverse function or the inverse, and we'll talk about what that means algebraically. So this is pretty easy. What you want to do is remember that the inverse and its function, the relationship is that x and y switches. So what was x is now the y, and what was y is now the x. So to find the function algebraically, what you want to do is just switch x and y and then solve for y. So it's pretty simple. So let's look at one example. If you have a function f of x equals x over x plus 1, and you need to find the inverse, whether that's a function or not, we'll talk about that. What you want to do is first switch x and y. So you know that f of x just means y. So what you want to do is just switch x and y. So x is equal to y over y plus 1. Okay, so now we want to solve for y. Now, if you kind of look at it, you would have trouble finding y because there are two y's, and it's not easy to solve for y when there are multiple of that same variable. So here's the trick. First, we want to just get the fraction to go away, so we do that, and then we would distribute. All right, so when we get to this point, you can see that there are still two y's, and we cannot solve for y by itself unless we can somehow combine those two y's into one y. And to do that, what we're going to do is move all the ones that have y's to one side, and then everything that doesn't have a y to the other side. I'm going to move everything to the left, but you can move it to the right if you want. And then what we're going to do is move the thing that's not a y to the other side. Okay, so we group them together, but that doesn't solve the problem. We still have two y's. So here's the trick, the final trick. What we're going to do is we're going to factor out the y. Okay, when you factor out the y, you basically change it to just one thing. And now we have only one thing to solve for, which is perfect. We can solve for y. So we're going to divide everything by x minus 1. Okay, so this is now the inverse. And I'm just going to write f inverse to indicate that this is an inverse. All right. Now, what we're going to do is look at the inverse and its original function, the domain and range of that. So let's first look at f of x, the domain and range of f of x. So the function is x over x plus 1. So if you recall, the domain is whatever does not make the denominator 0, because denominator can never be 0. So if there's an x value, which means domain, that's making it 0, then that number cannot exist. So looking at the denominator, we can see that x cannot equal negative 1. Okay, whether you write it this way or the interval notation, negative infinity to negative 1, parentheses, and then negative 1 to infinity, either way is okay. Know that both ways are acceptable, and eventually we're all just going to write it in interval notation and not in x not equal to negative 1. But for now, we're just trying to learn the domain and range, so we'll just write it like this for now, so to make it easy. Now range. You can find the range by graphing this and looking at it, or you can think about it. This is a rational function, x over x plus 1. So remember, a rational function usually has two things. One, a vertical asymptote, which is this number x equals negative 1, and a horizontal asymptote. How do you find a horizontal asymptote of a rational function? So kind of think back on the previous sections. It has to do with the degree of the numerator and the denominator. The degree of the numerator is the same as the degree of the denominator. Remember, degree means the highest exponent. So both of them are 1, so they're the highest degree of the numerator and the denominator. When the degrees are the same, the horizontal asymptote is the ratio of the leading coefficient. The ratio of the leading coefficient. In this case, it's just 1. So there is a horizontal asymptote at y equals 1. And because it's a horizontal asymptote, y is not going to be defined there for the most part. So for this one, the range is not equal to 1. Now I'm going to figure out the domain and range of the inverse function. So let's do the same thing as we just did of the original function. So let's first look at the domain of this inverse function. So again, this is a rational function, so we want to look at the denominator. We can see that in this inverse function, x cannot equal to 1. Okay, now we can look at the range as well by looking for the horizontal asymptote. If you look at the degree in the numerator and the denominator is the same, it's 1. And so what you want to look for is the ratio of the leading coefficient, which in this case is negative 1. So y is not equal to negative 1. Okay, that's good. Now, what we want to do is look at something more interesting. So remember we said the relationship between the function and its inverse is that x and y switches. And because x and y switches, that means domain and range must also switch. So you can see that the domain of the original becomes the range of the inverse. And this is always true. This is always true. So what you want to do is almost just remember that, once you find the domain of the original, you can just pretty much assume the range of the inverse will be the exact same number. So please just keep that in mind. And you can see that the same thing happens with range. The range of the original function is the domain of the inverse function. And so again, please remember that they basically always just switch, or not basically, they will always switch. So just remember that. Okay, let's look at a different kind of problem. So the problems are going to get slightly trickier. Okay, the question says, find the inverse of the function f of x equals square root x plus 3. State any restrictions on the domain of f and f inverse. All right, so again, to find the inverse, we want to switch x and y. So x is equal to square root of y plus 3. This is an easy problem, so what we want to do is just square both sides and then subtract 3. Okay, y is the same as saying f inverse. All right, let's go ahead and find the domain and range. So let's look at this original function. This is a square root x plus 3. So let's think back on the previous section where we memorized all of those parent functions. So this is a square root function. So square root, remember, is that one-winged bird. And this is moved to the left 3. So that's how it looks like. So what's the domain? Well, we can see from here it's very easily identified as x is greater than or equal to negative 3. Or what you can do is start from the original function, and you can see that square root something, that something always has to be greater than or equal to 0, because you cannot have a negative number inside the square root. So then if you solve for that, you'll see x is greater than or equal to negative 3. Okay, either way to think about it is fine. We'll just write that down. In front of the graph, you can see that the range, so all the possible y values are y greater than or equal to 0. Now, if you use the trick I showed you before, we know that domain and range must switch for the inverse function, or just the inverse. So we can just pretty much assume it's going to transfer over like that. So let me write it in, and then what we're going to do, oops, it should be x. What we want to do is actually solve for the domain and range by looking at the function. So let's take a look at the function. The function is x squared minus 3. So how does x squared minus 3 look like? Well, let's think. It is just the x squared graph, which is the parabola, moved down 3. So it is the parabola moved down 3. So what's the domain? Well, this is a parabola, so the domain must be all real numbers. And then let's take a look at the range. The range is from -3 up. So like that. Now, why is it different? So range is the same. It's exactly the same as what we predicted. However, domain in my prediction, it is only greater than or equal to 0. But if I look at the function, I say it's all real numbers. So which one is the correct one? Well, x greater than or equal to 0 is the correct one. So how does that work? Why is it not all real numbers? Because the function is x squared minus 3, isn't it? So what's going on? Why is this not true? Well, so what we want to do is come back to the graphical sense of inverse function. The graphical sense of the inverse function is that what we do is we take the original function and we flip it over y equals x line. Okay, so if you kind of look at that blue graph, when we flip that over the y equals x line, it actually looks like this. So not a full parabola. Therefore, it's only x is greater than or equal to 0. Or the other way to think about it is, so kind of you had to remember algebra 2. So when we have a square root like this, we are talking about the principal root. Principal root meaning we are only talking about the positive root. So when we don't write any sign in front of the square root, it is kind of taken as if we had a plus sign or a positive sign in front. Because if we wanted to say that this square root is negative, we would have put a negative in front. And so when we don't put anything, we're really just saying that it is a positive sign in front. Therefore, we're only taking the positive values for x. And so we're only looking at x greater than or equal to 0. The last way to think about this is you cannot have more numbers than you started with, right? So if your original graph is only this much, when you flip it over, you cannot all of a sudden have another part of the graph that didn't exist before, right? If it had to have been a parabola, then you should have this other part of the sideways parabola to begin with, which you didn't. And so you cannot magically have more numbers than you started with as a result of finding something of an inverse function. Therefore, the domain is only half of the parabola. So you got to be careful. And you can see why I was saying that to find the inverse and the range of the inverse function, you should just switch like this, and because it will always work. Okay. So let's go ahead and have you try one last one. This one is another tricky question, but I think you guys should be okay. So give it a try. Find the inverse of the function, and that function is x minus 1 squared. State any restrictions on the domain of f and f inverse. So go ahead and give this a try, pause the video, come back and check. All right, let's take a look. So I only wrote out one part of the possible answer because this is a trick question. So what is the trick? It's in the question. So the question says, find the inverse. Find the inverse. So there's a difference between inverse and inverse function. What is the difference between inverse and inverse function? Inverse just means flip this graph over the y equals x line, and what is it? That's really what inverse means. Inverse function means flip it over the y equals x line, but it has to, whatever result you get has to pass the vertical line test. It better be a function. That's what an inverse function means. So this is a trick question, and I didn't write it correctly, but I'll talk through it, and then you can see what the answer should be for each type of question. So let's talk about inverse. So if I just wanted to find the inverse, I don't really care if the result is a function. Then what I'm going to do is first we switch x and y, and then we try to solve for y, and you can see that the first thing I'm going to do is square root. Now when you square root, remember you have a plus minus. And then so the final inverse function is that it will have a plus minus square root x and then plus 1. Plus minus square root x plus 1, if you kind of remember, it's basically the square root graph but moved up 1. But there is a plus and minus, so usually this graph should just look like this, but there is a minus, so it has to also go below like that. Sorry, the graph is not perfect. But what we basically did was we flipped the parabola, the upright parabola, so that it becomes a sideways parabola. Then what is the domain and range of this inverse equation? Well, let's take a look at the domain and range of the original function. Because the original function is a parabola, the domain must be all real numbers, and for this one, the range is y greater than or equal to 0. So we can pretty much assume that it's going to switch. The range becomes the domain becomes the range. And if you could look at the red graph, you can see that that is true. The domain is x is greater than or equal to 0. The range is all real numbers because it is just a sideways parabola. Okay. However, if we are talking about the inverse function, then the red one is definitely not a function, right? To become a function, you need to pass the vertical line test, which it does not. So how do we make it so that it's a function? Well, let's take a look. When we square rooted that y minus 1 squared, we had a plus minus square root x on the left, but because it's a plus minus, it's not going to become a function. So what we can do is either we restrict it so that it's only the top half, or we restrict it so that it's only the bottom half. So either way, we would be able to make a function. So what we usually do is we keep it positive. So instead of having a plus minus, we would just have a plus. Okay, and then add 1 on both sides. So then the inverse function becomes square root x plus 1. Okay, if the inverse function, so notice how I'm calling this an inverse function now, is square root x plus 1. So that is this one here. Then what is the domain and range? The domain is still the same. X is greater than or equal to 0. But in this case, the range is y is greater than or equal to 1. So notice how it's not all real numbers anymore. It is greater than or equal to 1 because we're only keeping the top part of the parabola. So the trick is, what does the question ask? Is it asking for inverse? Then you just give the equation, or the equation after it's being reflected over the y equals x line, without caring whether the final inverse function is going to pass the vertical line test or not. But if the question asks for inverse function, then you need to restrict it so that it actually becomes a function. So a parabola is not going to have an inverse function. And also just kind of think about the previous section. how did you check to see if a function will have an inverse function? Use the horizontal line test. And so the parabola definitely fails the horizontal line test, so we know it doesn't have an inverse function. So if we do have to find an inverse function, then we need to restrict the range so that it will actually work. Okay, so that's a lot of information. I guess what you need to just remember is that this trick of switching domain and range will always work unless the original function you can already see that the inverse is not going to be a function. Then when you want to make it into a function, you need to restrict the range. All right, next thing, the last thing about a inverse is you want to be able to check whether someone gives you two functions and asks you, will these two become, or are these two inverse of each other? How would you be able to check that mathematically? So we say that a function is a 1-to-1. All right, so kind of recall 1-to-1. 1-to-1 means every x only has one y. So that would be a function, right? So with an inverse function g, so they're saying if f is an inverse of g, or if g is an inverse of f, so kind of vice versa like that, then only when f of g of x is equal to x. So composing f and g together, we end up with x. Then they are inverse of each other, or we can compose them the other way. And if we get x, then they are inverse of each other. So let's apply those rules. Let's look at first example. Show algebraically that f of x equals x cubed plus 1 and g of x equals cube root of x minus 1 are inverse functions. So if we want to show algebraically that this works, what we're going to do is apply what we just learned. Put g inside f, we should get an x. Okay, let's try that. So I know a lot of people struggle with composing, so what we're going to do is just take one step at a time. So we're going to put g inside f. So what I'm going to do is use f as a skeleton, which means I'm going to write x cubed plus 1. But I know I'm going to substitute x as something else, so I'm going to write it as a box. So box cubed plus 1. The next thing is, well, what goes inside the box? This tells me that g should go inside the box. So should be g of x cubed plus 1. Well, then what is g? G is cube root x minus 1. So in that box, I should put cube root x minus 1. And then the box is cubed, so I put a cube there, plus 1. Okay, now I'm just going to solve this. So cube root of something cubed is just taking off that cube root. This becomes x. So that's pretty good. So this shows me that they are inverse of each other. I'm going to do it the other way around, putting f inside g, and then just to double check to see if I have an x. Okay, again, g is the outside function, so think of that as the skeleton. Okay, what goes in is f. F goes in here, inside the box. So another way to write this is g of, and then it tells you that f is x cubed plus 1, so you're going to put x cubed plus 1. And then in that original box, we're going to put x cubed plus 1. All right, let's solve this. X cubed plus 1 minus 1 means that 1 is going to cancel, so we have a cube root of x cubed, which is x. So that does work. That tells me f and g are inverse of each other, and they're both functions. All right, let's go ahead and have you try one. This is pretty simple. Just be careful with your composing two functions. Give it a try. See if you get x for both ways, f of g and g of f. All right, double check your answers, especially the algebra part, making sure that it is following the algebra rules. So both of them equal to x, so that means f and g are inverse of each other.